Okay, here is a detailed explanation for the polynomial assessment. First thing, we need to simplify the expression. So we see that we have 4 terms, and those 4 terms are 3b, positive b. Those are like terms. Like terms have the same variable to the same exponent. So in this case, we have b to the first. Now notice we don't see the 1 in b to the first. We would never write b to the first. We would always write b. All right, and we wouldn't write 1b. All right, b is also 1b, and we would never write 1b. We would just write b. So those are like terms because they have the same variable to the same exponent. That's b to the first. This is b to the first. We are going to be able to combine those. The other terms in the problem are -5 and -4. That's why we have 4 terms, 3b, -5b, and -4. And the 5 and 4 are constants, so they are like terms. So we're going to combine those. And what I've been doing is something like this, 3b plus b minus 5 minus 4. So we have the like terms of 3b and b. We're going to combine their coefficients. The coefficient of the first term is 3. The coefficient of the second term is 1. When we see b, as we saw here, the coefficient is 1. So we have 3 plus 1, which is 4b. Then we have -5 and -4, which makes -9. So my answer is 4b minus 9. Now, another thing we have to remember is, I didn't mean to do that. Other thing that we need to do is standard form. Standard form. Our answers need to be in standard form. Standard form is alphabetical order. And constants come last. So the constant, the variable is always, the term with the variable is always going to go first. And if we have multiple variables, it's going to be in alphabetical order. And then if alpha order is the same, we would be in exponential order. And we'll see that in a second. Exponential order, numerical order. So there's only one variable, so that's going to come first here, and then our constant, -9. So when we have number 2 here, let's look at the like terms. We have n to the second. Oh, we have another n to the second here. We have n to the first and n to the first. So we're going to combine these coefficients. So we have -6n squared minus n squared, and then we have -3n and +2n. So we're going to look at the coefficients. -6 and -1 makes -7n squared. Notice the variable and the exponent come together. You're not adding the exponents, we're just keeping them. We have -6 of these n squares, and we have -1 of these other n squares. And so if you have -6 and -1, that makes -7n squares. The other like terms are going to be, coefficients are -3 and +2, which gives me a -n. Notice again, I did not write -1. -n is equal to -1n. We would never write -1n. We would always write it as n, -n. All right, and that's in standard form. Oh, so here we go, standard form on this one. So alpha order, well, notice they both have the same variable, n. This is n to the second, this is n to the first. So we're going to write n to the second before n to the first. That's why that came ahead of the n. Number 3, let's look for like terms. So I look at the first one, we have an n. Okay, there's a like term, negative 7n. Let's look at this. This is n to the third, and that's n to the third. I'm going to write the one with the bigger exponent, alphabetical order. They all have n's. So I'm going to write the 3n to the third plus 7n to the third, which is its like term. Then I'm going to write 6n minus 7n. We're going to combine these like terms. We're going to combine their coefficients. 3 and 7 makes 10n to the third. Then we're going to look at these two like terms. We're going to look at their coefficients. Positive 6, negative 7 makes negative 1. And we just write negative n. Number 4. Whoa, we got a whole lot more going on here. All right, we've got the constant of negative 6. We have another constant of negative 2. We have 7 to the fourth and 7x to the fourth and 8x to the fourth. And then we have 4x to the third, 3x to the third. So notice the x to the thirds make them like terms. So I'm going to write the 1, I'm going to go alphabetical order, and we notice that all these have x's, so I'm going to write the x with the biggest exponent first. So 7x to the fourth plus 8x to the fourth. Now I'm going to write x to the thirds, so 4x to the third, 3x to the third, negative 6, negative 2. So I'm going to combine the coefficients. 7 and 8 makes 15x to the fourth. I have coefficients of 4 and 3, which makes 7x to the third. And then I have the constants negative 6 and negative 2, which makes negative 8. Number 5, again. And you notice that I just start with the first term, and then I look to see, is there another like term with that? And I go with the second term. Okay, does that have a partner? Yeah, right there. K squared. Yeah, another k squared. Now I'm going to write the 1, so I have 8k to the third minus 8k to the third plus 6k squared plus k squared minus 5k minus 2k. So I look at the coefficients, because those are like terms. They both have k to the third. 8 minus 8 is 0. That equals 0. So I'm not going to write, there are no k to the thirds. If I wrote k to the third, which I saw a number of students write, you're telling me that there's at least one k to the third. There aren't. There's 0 of them. I don't know why you would write k to the third, because that would mean that there's at least one, and there aren't any. If you have 8 and you take 8 away, you don't have any k to the thirds anymore. So you will not see that variable. Then let's look at k squares. We have our coefficients of 6 and 1, which makes 7k squared. And then you have your coefficients of the k's, which is negative 5 and negative 2, which is negative 7k. Remember, it's in standard form. So I'm descending alphabetical order, and then if they have the same variable, it's descending, meaning can I get that away? There you go, good. K squared is going to come before k to the first. Let's look at number 6. Let's look at their like terms. You've got x squared. Oh, it has no partner, so it's standing by itself. There is no like term to x squared. We have x to the fourth, x to the fourth. We have x to the third, x to the third, and then we have a constant here. So I'm going to deal with my exponent, my variables, and then my variables with the biggest exponent. So we have negative x to the fourth minus 4x to the fourth. We have 5x to the third minus 5x to the third. We have an 8x squared that doesn't have a partner, and then we have the constant. So I'm looking at the coefficients. -1 and -4 makes -5x to the fourth. We have positive 5 and -5x to the third. Those are opposite of each other. Positive 5 and -5 makes 0. So we will not have an x to the third term. Then we have 8x squared that doesn't have a partner, so that just comes down. And we have our constant that also doesn't have a partner, and that'll just come down. This is in standard form. X to the fourth came before x to the second, and the constant is always going to be last. Let's pair them up. I loved all the highlighter. We have n squared, n squared. We have a constant. The constant doesn't have a pair. We have n to the third, n to the third, and then we have n to the first. So let's start with them. Biggest exponent, n to the third plus 7n to the third. We have -8n squared, positive 3n squared. We have an n and a -3. No partners for them. No soup for you. Coefficients 1 and 7 makes 8n to the third. We've got -8 and positive 3, which makes -5n squared. We have a positive n that doesn't have a partner, so that just comes down. And then we have a constant that also doesn't have a partner, that just comes down. Number 8. So we have x squared, -8x squared. We have -8x to the third, -2x to the third. We have 8x and -x. So everything has a pair. We're going to do -8x to the third minus 2x to the third. Then we're going to do positive x squared, -8x squared, positive 8x, -x. So coefficients, -8 and -2 makes -10 x to the third. We have positive 1 and -8, which makes -7x squared. And then the last one, we have a positive 8 and a -1, which is positive 7x. It is in standard form because my exponents descend. Last one to pair up. We've got a 4x and a 6x. We have a -7 and a -4. We have an x squared and a -4x squared. So x squared minus 4x squared plus 4x plus 6x minus 7 minus 4. We have a positive 1 and a -4, which makes -3x squared. We have a positive 4 and a positive 6, which makes positive 10. And then we have -7 and -4, which makes -11. All right, that's adding and subtracting. That's combining like terms. Now we're going to multiply. Now we can multiply these two terms. They are not like, but we can multiply them. And how I like to do it is you break each piece up, because 4k squared is 4 times k squared. So we're just rewriting it, and I just want to put my constants next to each other, and I want to put my like variables next to each other. So when we multiply like terms, what we're doing is we're multiplying the coefficients times the coefficients. The coefficient times the coefficient. So that's why we have this, 4 times 8. And then you're going to multiply like base with like base. So this like base, it has a k as a base. This also has a k as a base. So we're going to multiply these like bases together. When we multiply like bases, we add their exponents. These are not like bases. That's a 4 and an 8. Those are constants or coefficients. 4 times 8 is 32. And then we have k to the 2 plus 4. We add their exponents when we are multiplying like bases. So my answer is going to be 32k to the 6th. Number 11, we're going to have negative 2 times m to the 4th times negative 4 times m to the 2nd. So we have our constants, and then we have our like bases. Negative 2 times negative 4 is positive 8. And then we have like bases, so we're going to add their exponents. And that gives me 8m to the 6th. What number was that? 11. I just want to make sure I know I skipped a couple by accident. Sorry about that. On the pre-assessment. Negative 2 times v to the 4th times 8 times v. So we have negative 2 times 8 times v to the 4th times v. I'm pairing up the likes, well, the similar. We have constants in the first. We have v's as the other part. Negative 2 times 8 is negative 16. We have like bases, so we are going to add their exponents. Remember, there's an invisible 1 right there. So we need to represent that. That gives us negative 16v to the 5th. 4 plus 1. Number 13, we have negative 3 times y to the 4th times negative 4 times y to the 3rd. So we have negative 3 times negative 4 times y to the 4th times y to the 3rd, which would give me negative 3 times negative 4 is 12. We have like bases, so that becomes y to the 4 plus 3, or 12y to the 7th. Number 14, now we have 3 things that we're multiplying. So we're still going to break them up. Negative 7 times m to the 4th times 1. There's an invisible 1 in front of that coefficient, times m to the 4th times n to the 4th times negative 3 times n to the 2nd. So we're gonna pair them up, right? We have a coefficient or a constant. Coefficient. We have an m to the 4th, an m to the 4th. And we have an n to the 4th and an n to the 2nd. So a little bit different than adding and subtracting, because these are multiplying all the way across. It's times, 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 times. So all I'm doing is reordering so I can see what I'm multiplying. M to the 4th, m to the 4th, n to the 4th, n squared. So constants, negative 7 times 1 is negative 7 times negative 3 gives me a positive 21. M to the 4 plus 4, because they have like bases, times n to the 4 plus 2, which gives me 21 m to the 8th, n to the 6th. Got to make sure we can't combine these because those are different bases. I saw students writing mn to the 14th. Nope, we can't combine these two bases because they are different bases. This is m to the 8th and n to the 6th. Ooh, look at this one. So this is a tricky one. We need to see that that's a negative 1. There's an invisible negative 1. So it's negative 1 times x to the negative 3 times y to the 2nd. We've got some negative exponents going on in here too. Times 4 times x to the 1st times y to the negative 4 times negative 5 times x squared times y to the 4th. So we again are going to coefficients or constants out there. Those are going to be paired up. Like bases, that's a base of an x, that's a base of an x, that's a base of an x. We have y, base of a y, base of a y, base of a y. So we have -1 times -4 times -5 times x to the -3, x to the first, x to the second, y to the second, y to the -4, and y to the fourth. So let's multiply -1 times -4 is +4 times -5 gives me -20. We have x to the -3 plus 1 plus 2. And then we have y to the 2 plus -4 plus 4. -20. So -3 plus 1 is -2 plus 2 is 0. And then we have y to the 2 plus -4 is -2 plus 4 gives me y to the second. This needs to be simplified. That is equal to 1. Anything to the 0 power is 1. So this is multiplying. We're multiplying these things. So -20 times 1 times y to the second. -20 times 1 is -20. Y to the second would be my answer. Did I miss it? Are we already there? Yeah, 15, 16. Okay, 16 we have division. So much like we separated multiplication and we separated those things, right? 8 times v over 4 times v to the -1. Well, let's separate the constants, 8 and 4. And when we have like bases, that takes place in the numerator. We're going to combine like terms. Well, we're not going to combine. We're going to divide like bases. They both have the same base. This is a base of a v. This is a base of a v. We need to know that there's an invisible 1 there in that numerator v. So that's v to the 1 minus -1. We are going to subtract their exponents when we divide. So 1 minus -1. Lots of students did not have both of those negatives there. And now we're going to simplify. 8 over 4 simplifies to 2. V to the second. 1 minus -1 becomes 1 plus 1. Negative and a negative make a positive. And you get 2v squared. Number 17. Whoa. 17. We're going to separate them. And then we have x to the 4 minus 2. We are treating the constants different than the like bases. We do not subtract constants. That is not going to be -2 or 2 or anything like that. That is just a fraction 3/5. It cannot be reduced. There is no number that goes into 3 and 5. There was a number that went into 8 and 4, but there is no number that goes into 3 and 5. So that becomes 3/5 x to the second, and I'd much rather see it 3x to the second over 5. Both are acceptable, but this one is what you're going to see in high school more often. This 3 is in the numerator. This x squared is in the numerator, so that's why I was able to write it in the numerator. The 5 is in the denominator, and notice the 5 stays in the denominator. Number 18. So we have -8 over 2, and then we have x to the 0 minus, that's dividing, the denominator exponent, -4. -8 over 2 can be reduced to -4. And that becomes x to the positive 4. 0 minus -4 is 0 plus 4. That's why we ended up with that. We are not going to move this into the denominator because that's not an exponent. I saw students moving the 4 down. and making it positive. If we change this sign, we can't change the sign of the constants. If we want to do it to negative exponents, we can do that. And I think that there will be a problem coming up where we might have to do that. So let's deal with the constants. Negative 6/5, x to the 0 minus 0, y to the 4 minus 3. We have constants, coefficients. We have our x's, like bases, and our y's, like bases. And since we're dividing, we're going to subtract. So we have negative 6/5, x to the 0 minus 0 is 0, y to the 4 minus 3 is 1. I didn't put a, well, I put a 1 there for the time being. This must be simplified. We cannot leave x to the 0. So we'll get negative 6/5 y, which can also be written as negative 6y over 5. Notice I didn't write the 1. We do not write the exponent 1. It's just understood. Negative 2 over negative 3, m to the negative 3 minus negative 1, and then we have n to the second. It doesn't have any partner, but it's in the numerator, and this is all taking place in the numerator. We can simplify two negatives. A negative divided by a negative gives me a positive. Now, as far as the numbers, there's no simplifying 2/3. And then we have m to the negative 3 plus 1, which is negative 2, n to the second. Now in the directions it says no negative exponents. So I'm going to change this exponent from negative to positive. When I do that, this base that is in the numerator right now needs to go in the denominator. So 2/3, this base is going to go in the denominator. So that's m to the second. And this n was already in the numerator, so we're going to keep it up there. It's a little tricky, but it's a good one. You're going to need to know it. That's part of algebra. So we get rid of it. We change the sign of the exponent. We change the location of the base. It was in the numerator. Now it's in the denominator, and notice the exponent went to positive. We didn't have to do anything with this one because it has a positive exponent, so it can stay in the numerator. We'll put that back there. You have 6 over negative 4, u to the 3 minus negative 1, v to the 3 minus negative 3. 6/4 can be reduced. 2 goes into both of those. 3 over negative 2. That becomes 3 plus 1. So that's, whoa. See what I was about to do? If I wrote it there, it would look like it's in the denominator. I don't like that. I need it to be up here. So u to the 4th, and that becomes 3 plus 3, v to the 6th. I'm okay with that answer, but I'd rather see 3 u to the 4th, v to the 6th over negative 2. That negative can be in the numerator denominator or outside of it. Doesn't matter. So this is okay as long as you make it look like these are in the numerator. Make sure that they don't look like they're down here. Once you start putting them down here, then I'm going to have a problem with it because I can't tell. So make sure it's even with this division bar, or you can write it like this, which is how you're going to see it in high school. Hope that helps. Good luck on the reassessment.